Hello and welcome to a lecture on core mechanics of a video game. This unit and last unit on levels is really the heart of what it actually takes to make a video game, and we're going to be actually talking about computer science since this is for a computer science class today. Some very basic computer science, but this is at the heart of a video game. This is actually at the heart of every single computer program that you will ever write, is writing the core mechanics. It is unique to video games. The way we do it is unique to video games. Every computer program is different, the way you write it and the way you go about it. But core mechanics are key. So let's start back to our handy dandy little chart from the book. The player inputs their actions into the user interface. So the gameplay and level and challenge system was all about the inputs and how you input those into the user interface. Then that triggers player events. That means the player is doing something there. They are eventing something. They are doing something. And then you have that event goes into your core mechanics, which then triggers in-game events or storytelling engine, which is narrative events, and all that's communicated back out to the player through the user interface. So core mechanics in the bottom right corner here are the most important part of your game. So let's talk about what core mechanics are. To understand what they are, we have to go back to the very beginning unit of this class, which is 4 elements of a game, not a video game, just of any game. Remember, at the beginning of class, we said every game has to have 4 things or else it's not a game. It has to have a magic circle, which means it has to have something you're pretending. So we talked about the magic circle when we talk about the game world. When we talk about the story, we're pretending to be a character in the story, the avatar. All of that is your magic circle. Then we have victory conditions, a way to win and a way to lose. Then we have rules, which are what the player does. And then we have the gameplay, which is how the game is played. So the core mechanics are not the rules. The rules are what the player can and cannot do. So the core mechanics aren't the rules. The rules are what the player is and what the player can and cannot do. Gameplay is the core mechanics. Gameplay is how the game is played. It's how the turns are taken. What happens if something happens. In fact, we're going to use the word if a lot later in this lecture. And so a good way to think about it is rules are what the player can and cannot do, but the mechanics is how the game responds to the player. Rules are how the player plays the game. Mechanics are how the game plays back to the player. How the game takes a turn. In that. And so rules might say that the player must draw a card or the player must roll the dice. Mechanics are what happens when the card says 3 or when the dice is 6, adds up to 6. What happens then, right? Rules say that the player cannot I'm trying to think of an example. Cannot go 7 if the dice say 6. Mechanics are what happens if the player moves forward 6, but the board says go back 3. Or there's a chute or there's a ladder and the game shoots and ladders. Does that make sense? So rules are commands. You can do this or you cannot do this. They're thou shalt do this, thou shalt not do this. Mechanics are not shalts and do's and cans and cannots. Mechanics are ifs and elses and thens, which we'll get to later. So with that said, what do the mechanics do? How do the mechanics play back? What do they do? Well, one is if your game has an economy, they operate the economy of that game. 2 is they present the active challenge to the player. They tell the player, this is what you need to do now. This is what we are daring you to do now. This is the puzzle you need to solve now. This is the bad guy you need to shoot now. Things like that. They accept the player's actions. That should go without saying. They accept the 6 that the player rolled on the dice, and they detect a victory or a loss. They say back, you either won or you lost. And so you game overed or you won the game. Here's the end credits. They operate the artificial intelligence of the non-playable characters. That probably goes without saying. So you'll write mechanics that says if this NPC moves forward 3 spaces and they bump into a wall, then the NPC has to to turn around and go back 3 spaces. Or if they go left until they hit a river, and then they either die in the river or they turn around, or they turn left or they turn right. That's the AI of NPCs. They switch the game modes. We talked about game modes already in this class. They switch between game modes, and they decide when game modes are switched. So if the avatar moves on top of this square or within this many pixels, then the mode changes to a battle mode, right? They activate the storytelling components, which goes back to our little chart from a couple slides back where they trigger the storytelling engine, right? And so they say this is when this storytelling piece happens. So that's what the mechanics do. These are the 7 ways that the game plays back based off of the player actions, and the player actions are governed by the rules. The mechanics are the rules for the machine. So think about it that way. It's the rules for the computer. So with that said, here's some key mechanic concepts. If you know anything about computer programming, these 3 things will make a lot of sense to you. If you don't, they're not going to make as much sense, but that's okay. These will help you learn computer programming. And that is when you're writing your mechanics, you have to divide your game up into resources, entities, and attributes. Think with me here. Resources are objects the game can move or exchange. So examples of that is in a typical card game where you score points, or even think Pong, right? In Pong, you had a resource called points. So the game moved and changed the value of points based off of where the ball went and whether it hit a paddle or not and whose side it moved off on, right? Money. Think about an RPG game, or even think about city building games where you buy things with money, and so the game uses the money to determine what the player can or cannot buy. They determine how much money the player has to determine how far along the players come in the game, things like that. Weapons are a resource, right? So if you have weapons, you can shoot the weapons, or you can swing the weapons, and then there's all kinds of mechanics that come around the weapons. Like if I hit you with the sword, then this many hit points get taken away. If I hit you with a knife, then this many hit points get taken away. If I fire a machine gun off at you, every bullet counts for this many hit points that hit you, right? Even friendship in games is a resource. We're going to talk about Stardew Valley a little bit later. Stardew Valley, friendship is a resource. If you're really good friends with this person, then you get to take things out of their house, right? Experience points are a resource. So, I mean, I could make a list of 100 things that are resources in games. And experience points is if you have this many points, then you have this many level. And if you have this many levels, then you have this many hit points, then you have this many attack points, and you have this many defense points, etc., 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 right? Then resources. Once you've defined your resources, you divide them up into entities. An entity is just one particular instance of a resource. So let's use the resource weapons and pretend that it's a first-person shooter game. So an example of an entity, if our resource was weapons in general, an entity would be an assault rifle, or a pistol, or a lightsaber, or a dagger, or your fist, right? A fist even counts as a weapon, right? So that's a particular instance of a resource. And then an attribute is an entity that describes another entity. So we have an assault rifle, right? So we have weapons in our game. That's a resource. But then we have an assault rifle. But then the assault rifle has all kinds of attributes, which themselves are entities. An assault rifle has the amount of damage it can do. The assault rifle has how fast it fires. That's an attribute. The assault rifle in some games is how heavy it is. Some games, the player can only hold so much weight, and they can only bring so much weight around with them. And so the assault rifle might have a weight, and that would be an attribute. It might have different types of bullets. Assault rifle might be able to throw grenade bullets or explosive bullets. It might be able to shoot arrows. I don't know. And so how many bullets are in the assault rifle, or whether the assault rifle is actually shooting little grenades, explosive bullets, is itself an attribute. And so when you map out your key mechanics, list all your resources, and then your entities, and then your attributes, and that's how you begin doing your core mechanics. And so there's also simple entities, compound entities, and unique entities. And I'll show you what this is on the next slide. But simple is just one attribute. So think points in Mario. You just have one number that describes them. There's, so you have points, that's the attribute, that's the entity, and then the amount of points is the only attribute that describes them. That's a simple entity, just one attribute. A compound entity then is what the vast majority of your entities are going to be in your game. They have multiple attributes, right? So you have your avatars in RPGs who they have a name, right? That's an attribute. The name itself serves as an entity. The level they're currently on, that's another entity. And remember, the level is made up of experience points, and so you have multiple, like you have a compound with multiple attributes, but then even the attributes themselves have attributes, because attributes themselves are entities that describe another entity. So then you have weapons, what weapons and armor they're currently equipped with or currently carrying. That's gonna, that's something. And remember, weapons and armors themselves, there's so many of them. So once again, entities upon entities upon entities, attributes upon attributes upon attributes. Some games there's a race, right? So if they're this race, it changes something. If they're this other race, it changes something. How much money they're carrying, things like that. So that's a compound attribute. And then you have unique entities, which is there's only one of it in the entire game. And so the example there is your avatar. There's only one avatar that the player can control in the entire game. Maybe there's only one key that can unlock one door in the entire game. The game has multiple doors, but there's only one key that can unlock those doors. So maybe there's only one type of weapon in that game, or maybe there's one type of shirt that if the player wears this shirt, they get +10 to their attack, right? So that's an example of that. So here's the chart. This is from the book. So a simple entity is just how many points have you scored, right? It has one attribute, and it's the number of points that you've scored. Then you have a compound entity there, two attributes. The wind is a compound entity because when you define the wind, even when you're making video games, if it's windy in video games, and I've played plenty of video games that use wind as entity, you have how fast the wind is going. Which is going to affect things like how far the avatar can travel if they're traveling on the wind with the sail. If it's blowing really fast, they can go really far. If it's blowing slow, they don't go as far. And then you have the direction it's pushing. It's either pushing north or northwest or southeast or all the directions of the compass, right? Obviously, if the player is going against the wind, if the player is traveling southeast, then the wind's actually going to push them northwest, right? Or they're going to go really, really slowly depending on the speed. So that's a compound entity that has two attributes. And then there's they mapped out the avatar for you. Here's a compound entity containing another compound entity containing even more compound entities, which I was talking about on the other side. So you have the avatar. The avatar has a name, he has money, he has his current health, he has what race he is, he has where he is, his location. Then he has his inventory, he has 5 items, but inventory itself is an attribute, but it's an entity. So what is in his inventory? Well, he has a sword, shield, foot, helmet, armor, and you could go on. And then we know that there's different types of swords, different types of shields, different types of food, different types of helmets. So it gets complicated pretty quick, but if you can map it out in little charts like this, it really helps your programmer know how to code the game. So every mechanic begins by defining the numbers, the entities, and all of that. They're going to define that list of things from before. I'll click back to it real quick. They're going to define how things changes, define what challenge is active, define what the player can do, define if they've won or lost, operate the AI, right? So think of your game in that. I'd encourage you to just stop right now, and I'll go back to this slide. Stop right now and just think for 5 seconds, 10 seconds of the game you're working on for this class. What are your resources? What are your entities? What are their attributes? Just start listing them off in your head. What are the numbers the game needs to know in order to advance the game? Hopefully that helped. Now, chances are the list you just made in your head, there were 2 types of entities there. One was a numbered entity, which can be specified using numbers. Example of that would be anything that has points. Even bullets in a gun. You have 14 bullets in a gun, or you have 12 bullets in a gun, or you have 20, or you have 48. But then you have symbolic entities. Symbolic entities are things like water. Like if you have water, you're good. If you don't have water, you're not good. Now you can measure water in numbered ways, but a lot of games don't. Symbolic entities, I'm trying to think of other good examples. Right now, I love my children. That's a symbolic entity. If you were to ask me how much I love my children, I mean, I could give you a number, but, you know, I just love them, right? Some things aren't as easy as that. But here's the thing. In video games, everything has to be a number, or it has to be a binary on or off, which binary itself is a number. It's a 0 or 1. So binary just means you have one of it, which is a number, right? So in your games, things that are symbolic have to be numbers, or you have to make it an on-off decision. So examples of a binary symbolic entity is like a special key, which I mentioned earlier. If you have the key, you can unlock the door. If you don't have the key, you can't unlock the door. Tools. If you have this tool, you can perform this task. If you don't have this tool, you cannot perform this task. Conversation mechanics in games. If you have had this conversation with this person, then you can unlock this special thing. If you have not had this conversation, you cannot. And so conversation mechanics in RPG games are huge. So to give you an example of symbolic entities that are either numbers or binary, here's the relationship chart in Stardew Valley. Stardew Valley has somewhere around 30 townspeople that you can befriend. Friendship is a symbolic entity, right? If you were to ask me right now, like, am I friends with you? How do I know whether that's a yes or a no? Well, how Stardew Valley does it is they measure it with hearts. And every conversation with that person, you get some points. Every gift you give them, which is mapped on the right, you get more points. If you give them something they really, really, really like, you get 40 points. If you give them something they hate, you get minus 40 points. So notice how Stardew Valley has taken a symbolic thing like friendship, and they've numberized it. They've quantified it. They've added numbers so that every conversation gets you points, and every bad gift gets you negative points. And if you give them points on your birthday, you get more points. Birthday, by the way, is a symbolic attribute, but it's binary. It either is your birthday or is not your birthday right now, right? Today is either your birthday, the date you were born, or it is not the date you were born. So that's an example of, in Stardew Valley, their birthday is a symbolic binary relationship, meaning there's a switch in the computer program that says is birthday. And if you give them a gift on a birthday and it is birthday, then that equals 100 relationship points. So you guys are starting to get the idea, I would hope. Here's a great example of some more binary symbolic. So this is a numbered symbolic entity. These are binary. This is the tool list from Zelda Link to the Past, Super Nintendo game. Great Super Nintendo game if you haven't played it. All these tools you see where it says Y right there, item Y in the green box, all these tools represent binary symbolic entities. You either have the bug catching net or you don't. You either have the magic cape or you don't. You either have the magic mirror or you don't. And in the core mechanics of the game, it says that the game is programmed that if you have bomb and you hit Y, then the bomb goes down and then the bomb waits 5 seconds, then explodes. And then if there is a cracked wall and the wall is marked as cracked, cracked again is a symbolic entity. It's either cracked or it's not cracked, then the wall disappears and a secret path opens up, right? That's an example of core mechanics with symbolic entities. They either have to be numbers or they have to be on or off. In Zelda, most Zelda games, you have a special key that unlocks just one door. So it's you either have the key or you don't, and if you have it, you can unlock that door, and that door is either open or closed. Another binary thing. So every entity in your game has to be numbers or binary. That's just how computers work, by the way. Here are the steps to writing mechanics. 1, define your entities and your attributes. Just make a big long list of them. 2, define how and when they change. How does Link get the key? How do you get one more heart with one of the Stardew Valley characters? How do you lose hit points? How do you gain hit points? Things like that. So every entity and attribute, you have to define how the number change. And then you use those numbers or those binary on or off to define when events and processes are triggered. Hopefully you know the difference between an event and a process. But events happen only once, and they happen and they're done. A process begins and then ends. So you have your entities, your attributes, you define how they change, and then you define when those changes trigger either an event, like a cutscene you're going to watch once, or a process when something's going to start to happen, and then you have to define when that thing stops happening. So if I have 500 gold, then I will start to collect interest on my gold. But if it drops below 500, then I will stop accruing interest on my gold, right? If I spend more. So, and the way we do these 3 steps is we use conditional branching, which if you're a computer programmer, you know about conditional branching. It's what makes computer programs work. It is the most important, and I would think it's also, for me, I'll just say, it's one of the most fun things of computer programming. I really enjoy figuring out conditional branches. And so a conditional branch uses 3 wonderful words: if, else, and then. In fact, most computer programs, you don't even write then, it's just implied, but in your thinking, it helps to think of the word then. So if this happens, then you do this, or else if it doesn't happen, then you do this. And those 3 words are how you write your core mechanics. So here's some example of some core mechanics then, which will help bring all this together. So think about a first-person shooter, right? If the player has the machine gun equipped, so that's a big if. Machine gun, remember, is a resource. It's an entity. If they have 1 machine gun equipped, and if the machine gun has bullets, more than 1 bullet, greater than 1 bullet, or actually it should be greater than 0 on that side. If they have greater than 0 bullets, then when the player presses the trigger, so that's the player, that's their action, they get to press the trigger, machine gun will fire bullets until bullets becomes less than 1. When bullets hit 0, then you can't play anymore. And then if the player does not have machine gun bullets greater than 1, a message will appear saying you have no bullets, right? Or you'll make a have no bullet sound. Or the player, the avatar themselves, will say, I have no bullets. Oh no, or something like that, right? So that's a core mechanic. That's how you write it. You use if, then, and else. So if a player has a machine gun's a resource. Bullets are an attribute of the machine gun, so that's why you have to write and if, right? You can also write or if. Or if means I would write that if the player has a machine gun or if the player has a pistol, right? Because pistol works the same way as a machine gun. Or if the player has a I don't know, shotgun, although shotgun you have to reload every time. So you'd write the mechanics of a shotgun a little bit different. So that's a core mechanic. It's how the game plays back, but it needs numbers and it needs binary to make that happen because that's what computers are. Here's a core mechanic from a puzzle game. Let's say that there's a switch and you have some blocks. I don't know if you guys have ever played these types of puzzle games in video games. I encounter them all the time. Zelda does a lot of these. I think Skyrim did 1 or 2 of these. So you have blocks on ice. Mario Odyssey had 1 or 2 of these. So you have blocks on ice. So if the player pushes the block, so once again, starting with the player's action. So we could also say when the player pushes the block. And if the block is on ice, ice itself is another entity, but it's a symbolic entity, right? How much ice, you might ask? Well, we're not measuring how much ice. It's either on or off. It's binary. If the block is either on ice or it's not on ice. So that's a binary attribute. So if the block is on ice, then the block slides until it hits the wall. And if the block stops on the switch, if there's also a switch against the wall, then the door opens. I didn't have room on the slide. I could also say else the player needs to push the block again, right? Or else door stays closed, although that's probably implied. So that's the core mechanic from a puzzle game. So the player action is they get to push the block. That's what they get to do. If it's on ice, if ice equals on, then the block slides until it hits a wall. And then you would write another mechanic that says what happens if ice is off? If ice is off, then maybe the block just moves 1 square. Or maybe the block doesn't move at all. Maybe the player can't move it because it's some rough ground, right? So that's a good example from a puzzle game. Here's a core mechanic from a city building game. This also works into this discussion, the ideas about processes. So these, by the way, would be events, right? Block stops on a switch, door opens. That's one event. It happens once, and it's a one-time thing. Whereas a process, you have to define when it starts and when it stops. So we would say in a city building game, if player builds refinery, or when refinery is built, then oil, the amount of oil the player has, begins increasing by 1 every 2 seconds. So oil is a resource. And it has an attribute of a number. You have 5 oil, or you have 40 oil, or you have 0 oil. Then, so if the player has a refinery, then they get 1 oil every 2 seconds, right? If the refinery is destroyed by a fire, let's say this city building game has events and a fire can trigger. By the way, if you do have that event, you have to, fire is itself another attribute. You have to write another core mechanic for when and how fires happen. Then oil stops increasing by 1. So, which means if you have it, you get it. But when the refinery is destroyed, or even if the player sort of decides they want any more and they destroy it, then they don't get oil, right? It doesn't decrease, but it just stops increasing. So that's a process. We begin a process of oil increasing, and that process is ended if the refinery is no more. And then we might say if the player upgrades the refinery, maybe the refinery has level 1, level 2, level 3, which by the way would be a numerical attribute to the refinery. So the refinery, the first one is just binary. Now it's actually numeric. If they have level 2 refinery, then oil increases by 3 every 2 seconds. Maybe we say if it's level 3, then it's 6 every 2 seconds. Maybe it grows sort of exponentially there. Maybe if it's level 4, 12. That's a core mechanic. We say if this, then this, right? One more example from a soccer game, since I know many of you make soccer games. If the avatar hits the kick button, once again, we start with a player trigger, right? A player action. The player hits the kick button. And if the ball is within 40 pixels of the avatar, you have to define that. You have to say the ball has to be this close to the avatar. It has to be right next to the foot by 40 pixels. So that means figuring out when you kick a ball, how far out you can kick to actually get the ball. My guess is it would be about 2 or 3 feet for me. I have long legs, but you'd have to measure that, but then you'd have to define it into pixels because everything in computers is pixels. Then if the ball is within 40 pixels of the avatar, which by the way isn't much, especially if you have a 4K TV, and the avatar hits the kick button, then the ball will reverse direction, right? And roll in a straight line until it either goes off the field or another player avatar kicks it, right? By the way, at this point, you'd actually have to write another mechanic for what happens when the ball goes off the field. What's going to happen there? How is the game mode going to change? How is what's going to happen, right? Or else, that's it, if the player doesn't hit the kick button, or if the ball is outside of 40 pixels of the avatar, what's going to happen to the ball then? Well, we would say it would continue rolling past the avatar. So if they hit the kick button and the ball is 60 pixels away, that means they kicked dead air and the ball rolled right under their lifted leg and kept going, right? So that's core mechanics. It's all define your attributes, which by the way, in computer programming, we call variables, and then define your conditional branches, and you have written a core mechanic. So that's the game. Here are some parting thoughts on this process. One is I love that these all come from the book. The book is basically saying, the author of the book is saying, don't be overwhelmed. Just strive to make it simple, right? Strive to make it elegant. Don't feel like you have to write a core mechanic for every single possible thing that happens. Instead, look for patterns and generalize. So the reality is I don't have to write, if we go back to the first-person shooter, I don't have to write this for machine guns and then write another one for pistols, then write another one for rocket launchers, then write another one, right? Instead, I can just say all guns, any attribute that is any entity defined as a gun is a resource, any entity of that resource is going to operate by this mechanic, right? I don't have to write it over and over and over and over again. I could just say guns, right? So pick up on the patterns, right? And generalize. And so once again, with the city building game and the refinery, I could say refineries make oil, and solar panels make electricity, and water pumps make water. And I can say for every single one of those buildings, I could say that if it's level 1, that resource, they get 1 resource every 2 seconds. If it's level 2, they get 2 every 2 seconds. If it's level 3, they get 4. And so just generalize it. Look for patterns. Don't feel like you have to write a core mechanic for every single possibility. Just and don't try to get it all perfect right away. Don't try to think you have to get it all perfect. Just play around, have fun with it, type it in, prototype your game. Make a prototype, have fun with it, and find the right detail for your game. Some games don't need a lot of detail. Some games, other games need very specific detail. If you're writing a short game, then you're going to need very specific detail, but your game is short, so it's not going to create that much paper on it. So if you're making a really big game with a lot of things going on, you know, you're going to want to find the right amount of detail for your game. So basically, this last slide is just saying start small. Just start with one entity. Start with one resource. Start with one. And figure that out, and then move to the next. And don't try to overthink it, right? Just play around with it. So hopefully you understood some of that. If you didn't, send me some questions. I think this is fun. I think figuring out all this stuff is the most fun part of a video game. This stuff energizes me more than, say, you know, the graphic design of your game world and your user interface. So I really like core mechanics. So hopefully you will too once you get into it. Just don't get overwhelmed. Just start small. So let me know what questions you have, and God's blessings upon you.